I know the place pretty well and been here through the good and the bad. Basically, want to talk to you about some of the testing that we do here in the lab on incoming parts, and also evaluations that we perform on the materials and the parts before we ever put them in production. This is just a book of the work instructions that we do actually here in the lab. So there's actually work instructions for every test that we perform in the lab on our materials and parts. Some of the tests that we perform are weather-armor and UV tests. If it's gel coat, for instance, we have weather-armor testing done to determine our weathering resistance. Blister testing, actually we do this in-house, make panels and check the laminate for blister resistance. UV testing, vinyls, other upholstery type material, just for instance the thread, Regal logos, Regal acrylic parts. We get raw stock in, we check that for UV resistance, the raw stock, the UV, the acrylic. Salt spray tests. We do salt spray testing on all of our stainless that we get in here. That's very important because there's tons of different stainless out there, but there's some that's not that good anymore, especially with all the stuff that's imported anymore. So it's very important to be selective on stainless and actually to do periodic retests on stainless too. Some of the tests that we perform on the parts themselves after they've been built is glass to resin analysis. This is a cutout of a part that was actually burned out. Basically, you put this in an oven for an hour at 1,000 degrees and it burns out the resin. So if you weigh the piece before and after, you get a ratio of how much resin and glass there was in the sample. That's good because if it's too wet, if it's too heavy, the part will be more crack resistant and it'll be heavier, so you won't get the performance out of the boat if it's a big part like a hull or deck that you would have gotten. On the other hand, if it's too dry, you could have more cracking issues because you could have structural weakness in the part itself. This is just a lens scope magnifying glass. Basically, you look through this to check the cross-section thickness and layers of each laminate you put in there. You can check and make sure they put the proper layers in there. Some of the process control tools they use out on the floor are gel coat mill gauges, for instance. Gel coat application. If you see anybody gel coating a mold and you never see them ever use a mill gauge on it, they're not really a professional gel coater, because nobody can actually gel coat a mold, especially a complicated mold, and get it within the range that you want it. Because, for instance, our gel coat spec on our wet millage for a deck is 15 to 18 mils. Well, this sheet of typing paper here is 3 mils. That gives you an idea of what kind of thickness we're looking for. So it's basically impossible for anybody to be real accurate in spraying that material on, being it goes on so quickly, and knowing how much they get on unless they actually gauge it. We have different thicknesses for different areas of the parts and different parts too. For instance, the hull bottom we wanted to put a little heavier on, so we have 28 mils wet on the bottom of a hull, whereas a deck we have about 16 mils for a deck ideally to get 16 mils wet. So for a hull you're looking for more blister resistance. You're not looking for UV resistance or crack resistance as much on the bottom of the hull. On a deck you're looking for more UV resistance, and also a deck, being it's a complicated part, if you start out with a heavier baseline for your gel coat thickness, you're going to get even heavier buildup in your harder areas to spray, like the top of your gunnels and your radius areas in real tight areas where you might have to actually go in. You've got maybe 5 different potential areas that you're hitting the same spot every time. And the gel coater has to be conscious of that all the time and back off when he needs to back off. That's why he has to use the gauge. Chop gauges. Obviously these are used when they're putting on the gun roving on the skin coat and in the bulk layers, wherever they may use the chop that's sprayed on the gun. You'll see that as they're in process out there. This infrared thermometer, we use these to check the materials of our drums and our resins, gel coats, adhesives. Basically, also important to know that your material's warm enough to use and not have issues with it. Like today. Now, all of our bulk resin tanks actually have warming and cooler units on them, so we're not too worried about them because they maintain a good temperature. Some of the other tests we do on gel coat is a hide chart here. We check for hide capability. Basically, you pull the gel coat down with this bar that pulls it down at a specific millage, and you know you've got a good hide whenever the black cross section areas disappear behind the gel coat film. Obviously, if it doesn't, then you've got a bad gel coat, because you don't want to have to put gel coat on too thickly to be able to get that hide capability. You have a spec that you want to put it on and stay within that range, so your gel coat has to meet that criteria. This is just the fineness of grind gauge. Basically, you check for particle sizes here. It's important that your particle sizes not be too thick, too heavy in your gel coat, because if they're too heavy, you can have patching issues. It'd be hard to patch, and it might not weather very well either, and it might not sand and buff out as well as it normally would have if the particle sizes are too heavy in your gel coat. That's an important test too.
Touch on it a little bit, Jimmy. I didn't really understand that.
So you put gel coat on there?
You put gel coat up here. Basically, it goes from a thicker to a thinner scale. In other words, this is ground very precision like these tracks. So you're thicker, you're deeper up here. You go out here to where you're actually zero at this point. You're actually totally flat. So as you pull that down, you see where the particles actually start showing up. They'll show up as like little bumps. Where you see those bumps come across, all the way across, then at that point, that's what you call the grind level.
Okay.
You call that the grind level. And like I said again, the particles, you don't want them too large, because it can be difficult to patch that gel coat, because you'll end up having halos and so forth in it. And also, it might not sand and buff out as well, nor weather as well, if the particles are too large.
Did you get that? Put white gel coat on there, or?
Oh, it can be any color gel coat. Absolutely any color.